Hello everyone. What we'd like to do in this video here is use the law of sines to solve a SSA triangle. We have to be careful with these SSA triangles. They are the ASS triangles. That's how you should remember that you have to be careful with these ones. Because if we are given two sides of a triangle and we're given an angle where the angle is not necessarily between those two sides, we could possibly get one of three situations. We could get two possible triangles, one possible triangle, or we could get no possible triangle. And we'll go through all three of those cases. Okay, again, this is a situation where you'll be using the law of sines. So just as a quick reminder, this is what the law of sines says. Now, I'd also like to note here is that, again, when you're just kind of given information and you don't know whether to use the law of sines or what we'll soon see, the law of cosines, I don't really have this memorized that for SSA triangles I have to use the law of sines. I take a look at the picture and I think about what do I have, what tools can I use for that type of situation. But in general, for the SSA triangle, you will have to realize, or you'll come to realize, that you will need to use the law of sines here. So let's get started. Okay, so let's say we are given the possible information. So here's our example one. Okay, so let's say they tell us that we have a side length A of 10, we have a side length B of 16, and we have that the angle A is 30 degrees. Okay, let's go ahead and draw this picture. So we know that we have an angle A, it's 30 degrees. Okay, so this is an acute angle. Okay, so we know for sure that angle A is 30 degrees. Okay, what else do we know? What else do we know? Okay, well, we would know that side length B, so if this is angle B over here, we would know that this side length here would be 16. So let's kind of draw that out, 16. And we know side length A here, so this will be A, and we know that it's a little bit shorter than 16. You'll see how that'll kind of come to play in here in just a second. Okay, so what we have here is when we draw this 10, well, we don't know what angle B is, so there actually could be two possible situations. Well, we could have this length here be 10. Okay. In this case, angle B here, angle B is acute. But it is possible for us to draw this side length 10 if we kind of make it go in a little bit. So we could have this triangle where B is acute, but we could also have this angle here could be B, and B, I'm going to say B could be acute, or B could be obtuse. So notice here, I don't necessarily know which triangle is going to work here. It could be either or. So we could possibly get two triangles in the situation, and we'll have to think about both of those. Okay. So which case are we in? For right now, let's draw the picture like this. Let's draw the picture like this. So this is 10. This is 16. We know that this angle right here is 30 degrees. Okay. So we still need to figure out this angle A. We still need to figure out angle B, angle C, and side length C. Okay, let's first start by trying to find angle B. Okay, so let's try to find angle B. Well, since I don't know all three of the angles, I can't use that trick in the last video where the sum of the angles add to 180 degrees, but once I find angle B, I can easily use that trick to find angle C. Okay, so what can we do here? I need to find angle B, so I'm going to write the law of sines saying the sine of B. Okay, sine of B, okay, well, divided by its opposite side would be 16. Okay. Now I need to get something at equaling to where I would know the angle and the side. Okay, well I don't know angle C, I don't know side length C, so I have to use A here, is equal to, this will be the sine of 30 degrees all over 10. Okay, so we'll have that the sine of B, what I'm going to do is I'm going to multiply both sides by 16, will be equal to, this will be 16 times the sine of 30 degrees all over 10. Now you don't necessarily need to simplify this right-hand side. You won't always be able to simplify the right-hand side. But I do have a nice angle here, 30 degrees. That's a nice angle on the unit circle. So let's clean this up a little bit. This is actually the same thing as us writing 16/10 times the sine of 30 degrees. Okay, 16/10, that reduces to, let's see, that would reduce to what, 8/5 times the sine of 30 degrees. What's the sine of 30 degrees? We put down our 30-degree finger. That's the y-coordinate. That would be 1/2. So 1/2. Okay, so I think this is going to be 4/5. So what we have is we have that the sine of B is equal to 4/5. So I need to figure out what B is. So B here, I could use the inverse trig function. B will be equal to the arcsine, or sine inverse, of 4/5. Okay, so now we can use our calculator. Okay, so sine inverse, we'll use our sine inverse button. Sine inverse of 4/5. Now, notice that we're working in degrees, so you want to make sure your calculator is in degree mode if you want this to spit you out an angle in degrees. So this is telling me that B is roughly 53.13 degrees. Now we need to be careful to interpret what this is saying, or we need to remember how sine inverse functions work. Remember that sine inverse, it only spits me out an angle that is between, I guess, 90 degrees, negative 90 degrees, and 90 degrees. Okay, so what we should be careful with is noticing what we're asking here if we're thinking about the unit circle. Here's the unit circle. We're looking for a height of 4/5, so here's 4/5, and I want to know what angle gives us a height of 4/5. Well, do we want the obtuse angle that gives us that? This would be the obtuse angle. I'm sorry, this would be the acute angle. It's the one between 0 and 90 degrees. Well, do we want the acute angle, or do we want the obtuse angle? But remember how sine inverse works. Sine inverse is only going to spit you out the angle between negative 90 degrees and 90 degrees, or negative pi over 2 and pi over 2 radians. So your calculator is only going to spit you out the acute one. The acute one. We need to mentally make sure that, well, what could we have? B could be this acute angle. It could be this acute one, or if this is still 10, it could be the obtuse one. We have two possible triangles to think about. So we have to look at both of these. We have two cases. So I'm going to erase a little bit what we have here. So we have case 1. We'll do both of them. We have case 1. Well, we just saw that B could be 53.13 degrees. 53.13 degrees, that's one possibility. But if we want to think about the obtuse angle, the other possibility, okay, what we're at 4/5, we were looking for this height right here. So this could be angle B, but this larger obtuse angle, we could also want to think about this one. Sine inverse doesn't tell us that one, we have to think about it. Well, how could I get this angle, this larger angle B? I could take 100, well, right now this angle B here is what? This is 53.13 degrees. So if I want to know this larger angle B, I could take 180 degrees and subtract off 53.13 degrees to get the obtuse one. Case 2. Case 2. Angle B could be equal to 180 degrees minus 53.13 degrees. So in this case, we'll have 180 minus 53.13. So we could have the obtuse angle 126.87 degrees. We'll need to think about both of these. Let's draw these. We have this case here. We have this case here. We have 16, 10. This would be 53.13. This would be 30. We still need to figure out C and C. Angle C and side length C. Okay? We could have case 2 over here. Case 2 would be this triangle. We would still have 30 degrees, but now, see if I can draw it a little bit better. So this could be 16, this could be 10, this would still be 30 degrees, but now this angle here would be 126.87 degrees. We would still need to figure out angle C and side length C. So we have these two situations we have to look at. So this would be A and this would be B. Okay, so we have to solve both of these. Okay, let's see what case 1 would be. I mean, this might be a good time for you to pause the video and try to figure out. Maybe pause the video and try to complete the triangles for each of these cases. Okay, let's find angle C. So angle C here, since I know what angle B and angle A is, angle C will be 180 degrees minus 53.13 degrees minus a 30 degrees. So let's see what we get here. So we'd have 180 minus 53.13 minus 30. C could be 96.87 degrees. Okay. So let's write that up here. So we know that this is going to be 96.87 degrees. Okay. Well, now we can figure out side length C. So here we would have that side length C over the sine of 96.87 degrees. That could be equal to, you could use A's or B's here. How about we say 10 over the sine of 30 degrees. Okay, so C is going to be equal to 10 over the sine of 30 degrees times the sine of 96.87 degrees. Okay, let's check this out. So we'll have 10 times the sine of 96.87 divided by the sine of 30. Okay, so I'm getting C. I'm getting that C could be equal to 19.856. So C, in this case, would be a 19.856. So here's our first possibility. Okay, for the second possibility, let's see what we would get. Okay, well, angle C is going to be 180 degrees minus 126.87 degrees minus 30 degrees. Okay, let's see what we get. 180 minus 126.87 minus 30. So we'll get that angle C here will now be 23.13 degrees. Okay, so this angle here will be 23.13 degrees. Okay, let's figure out what C would be. So we'd have side length C over the sine of 23.13 degrees. Okay, that'll be equal to, I don't know, how about we also do 10 over the sine of 30 degrees. So we'd have that C be equal to 10 over the sine of 30 degrees times the sine of 23.13 degrees. So we'll get C in this case. It's going to be So 10 times the sine of 23.13 divided by the sine of 30. So what we get C here would be 7.856. So C here would be 7.856. And there we have it. For this specific situation, if I want to find I want to find triangles that have these as sides and this is an angle, well, we found in this situation there were two, so we want to record both of them. We got two triangles out of this information. Okay. This won't always happen. In this case, we saw that there were two possible triangles that meet these conditions. Okay, let's do another example. Let's do another example. Okay, let's go ahead and try this example. So let's draw our picture. What we know so far for drawing this is we have our angle A, in this case is 30 degrees. Okay, so this is 30 degrees, this is angle A. Okay, we have that side length A here. We have side length A here. Well, notice this is bigger than side length B. This would be 16. And this side length A has to be a little bit bigger. So this would be 20. So notice here we do have the side-side angle triangle. Okay. So in this case you would just note that this is an SSA triangle or the ASS triangle, and you would be a little bit worried. So what we want to be able to do here is we want to figure out what angle B here is going to be. So we still need to figure out angle B. We need to figure out angle C, and we need to figure out side length C. Okay, we're going to go ahead and solve this one, but what I'd like to say is we're actually only going to get one solution for this one. Since this side length A here is longer than this one, we won't be able to get two triangles. Notice I can't take, if I kind of draw this horizontal line here, if I tried to kind of reflect this to the other side, since this length here is longer, the triangle would kind of look something like this, which would ruin angle A. You see how that would break it? So we'll actually find here that we'll only have one possibility for a triangle. Now you can go through this algebraically without having to, usually you can draw these ahead of time and realize if you'd have two solutions, one solution or no solution. But there's always an algebraic way you can check if you're maybe having trouble looking at the pictures and figuring out how many possible triangles you could get. Okay, but let's go ahead and try to find angle B here. So if we tried to find angle B here, okay, angle B, well, this could be what? We could get 180. Well, angle B, let's see, we would have to do the sine of B over 16, and that would be equal to the sine of 30 degrees over 20. Okay, so here we would have that the sine of B, I'm going to multiply both sides by 16. This will be 16 times, how about 16 over 20 times the sine of 30 degrees. Just multiply both sides by 16. I kind of did some rearranging, but if you multiply both sides by 16, this would be the same. I mean, if that's throwing you off, multiply both sides by 16. multiply both things by 16. Think about 16 over 20 times the sine of 30 if you want to think about this over 1. Okay. So what do we have here? Well, this is the same thing as what 16 over 20, 16, what 4 goes into there 4 times, 4 goes into 20, what 5 times? The sine of 30 is 1/2. So what do we have here? This will be what, 2/5. 2/5. So if I want to figure out what b is, so here we have b will be equal to the sine inverse of 2/5. Now we just need to remember how sine inverse works. So if we're drawing, or if we're looking at the unit circle, I'm looking for angles. I'm trying to solve this equation. I'm looking for an angle B that gives us an output of 2/5. So here's 2/5. That's the height of 2/5. We'll notice that there are two angles that get us there. We have the acute angle, or we have the obtuse angle. So we'll want to consider both of those. Okay, sine inverse is going to spit out the angle that's between negative 90 degrees and 90 degrees. So your calculator will always tell you the acute angle. You need to do 180 minus that acute angle to get the obtuse one. Okay, so let's see what we have here. So we have sine inverse of 2/5. Okay, sine inverse of 2/5. My calculator is telling us that this is 23.578 degrees. Okay. So let's write down the two cases and examine both of them. We're going to get a contradiction with one of them. Okay, so we have case 1. We could have that angle B is equal to a 23.578 degrees. We could have case 2. We could have the obtuse angle. Case 2, we could have that angle B will be equal to 180 degrees minus 23.578. So what are we going to get here? So we're going to get 180 minus a 23.578. So 156.422 degrees. Okay. So let's draw for case 1. For case 1, let's draw the triangle. So what do we have here? This was 16. This was 20. We're saying that this angle here is 23.578. We know that this angle here is 30 degrees. This is B. And we don't know C or side length C. Okay, so let's figure out what angle C would be here. So here we'd have that angle C would be 180 degrees. 180 degrees minus 23.578 degrees minus 30 degrees. So we'll get 180 minus 23.578 minus 30. So I would get that angle C would be equal to 126.422 degrees. Sweet. So this angle here would be 126.422. Okay, so now we can figure out side length C. So C all over the sine of 126.422 degrees. That's going to be equal to, let's use 20 over the sine of 30 degrees. So C will be equal to 20 over the sine of 30 degrees times the sine of 126.422. So let's see what we get. So we'll get a 20 times the sine of 126.422 divided by the sine of 30. So I get that length C is going to be approximately equal to 32.1866 or 87. So this side length here would have to be equal to 32.187. Okay. And there we have, this is the triangle for the case 1. Okay, let's look at case 2 here. Okay, could we possibly have angle B be 156.422 degrees? Well, in that case here, that'd be saying that this angle here would be obtuse, so this side would have to be kind of folded in. Hopefully you can visualize that this will be impossible, but the math is going to tell us that this triangle is not possible. Because notice what happens. Notice what happens if we try to find angle C. Well, that would be 180 degrees minus 156.422 degrees minus what, 30 degrees? 30 degrees? Well, what's this going to give us? This is going to be 180 minus 156.422 minus 30. I get out a negative 6.422 degrees. This is a contradiction. This is a contradiction. With any sort of triangle, all these angles here should be positive. By you trying to find angle C and it giving you a negative answer, this is telling you that this is an impossible triangle, which hopefully you can see here that this would have to be impossible. This would have to be an impossible triangle if this is 16 and this here is angle A. If this here is angle A and this is 30 degrees, this is angle A. Well, if this length here is longer, it has to only be able to connect right here. Otherwise, this wouldn't work. This would be 20 if this angle was obtuse. This is an impossible triangle. This is an impossible triangle. It won't be able to work here. It giving us a negative angle here for C is telling you this is a contradiction. So for this situation, there's only one triangle that meets the condition. Okay. Let's take a look at one more case. Let's do one more situation. Okay. Example 3. Example 3. Okay. So here's our next example. Let's say we're given these two sides and this angle, and we want to find all triangles that have this condition. Go ahead and pause the video and give it a shot on your own. Okay, let's go ahead and draw this. Okay, so here we have this angle A here is 30 degrees. So here's angle A. Okay, it's saying that side length A is 7. So it's saying that this side length here is 7. Okay, this would be angle B, and it's saying that this length here is 19. Let's attempt to solve this triangle. So we still need to find angle C and side length C. Okay, so let's give it a shot. Let's try to find angle B here. So we would have sine of B all over 19 would be equal to the sine of 30 all over 7. Okay, we can multiply both sides by 19. So we'd have that sine of B would be equal to 19. How about we write this as 19 over 7 times the sine of 30 degrees. So we just multiply both sides by 19. But this is sine of B. Well, notice that sine of 30 degrees. Sine of 30 degrees is 1/2. So this is 19 over 7 times 1/2. So what is this? This is 19 over 14. So I want to know sine of B is equal to 19 over 14. Before we do anything, we already have a contradiction. This is asking what angle outputs you a sine, what angle sine of what angle gives you an output of 19/14. Notice that this is bigger than 1. Sine only spits you things out between 1 and -1. This is outside of the range of sine. So there is no b. Already we have a contradiction. Sine of any angle, I'll put a theta here, sine is only spits you out things between -1 and 1. So there is no angle there's no angle here. No angle b here will work. And notice that even if you didn't notice that you're going to get a contradiction here, if you try to solve for b and say b is equal to the sine inverse of 19/14, just try plugging this into your calculator. See what it says. Sine inverse of 19/14, it's saying domain error. Domain error. Your calculator's going beep, 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 beep. This is impossible. This doesn't work. Sine inverse, remember, sine inverse only eats numbers between -1 and 1. So this 19/14 is outside the domain of sine inverse. Of course it's going to give you an error. Sine can only spit you out things between -1 and 1. So sine inverse can only eat things between -1 and 1. So we have an error here. We have a problem. This is an impossible triangle. And you could think about why this is an impossible triangle. No triangle can meet this condition. Well, the reason is I kind of didn't draw this correctly. You know, I forced these to connect. But since this is 30 degrees and this length 19, this is long enough to actually, if you think about this piece here, 7, this piece is too short to connect. It's just dangling here. We just have this. We have this little 7. It's dangling here, and it's not tall enough. It's not long enough to connect. So I'm not gonna get any triangle here that works. This is an impossible triangle. So here we have no solution. There is no triangle. Rather than no solution, we should say no triangle. So there is no triangle that meets this condition. So that's what we have. So we have to be careful with the SSA triangles. We could get one of 3 situations. We could get that there could be 2 possible triangles that work. We could get that there's 1 possible triangle that works. Or we could get that there's no possible triangle that works. You got to be careful in these situations. So just take your time. Try to draw a good picture. Try to visualize what's going on here. And we'll be okay. What we're going to do in the next video is we're going to start talking about another tool, the law of cosines. See you there. Take care.